Today we will be doing a very important reaction in organic chemistry, that is called ozonolysis. So, what is ozonolysis? It is basically an oxidation reaction with ozone, O3. Okay. So, now what is this ozonolysis? Okay. Ozone means ozonolysis is a two-step reaction. In the first step, we will be treating with ozone, O3. Okay. In the second step, lysis, okay, so that is breaking of a bond. So, we will be using zinc and water. So, these are the two steps involved in the ozonolysis reaction. So, what kind of reaction compounds will undergo this ozonolysis? This basically it is reaction with alkenes. Okay. So, now we will start the reaction now. First, let us start with a symmetrical alkene, that is ethene, that is CH2 double bond CH2. Okay. Now, what is the first step? We will start reacting with ozone, that is plus O3. So, when we react with O3, the cleavage of this double bond will take place, giving a ozonide, that is CH2, CH2. This double bond will be cleaved and the O3 ozone will get attached in this way. So, this we will usually call it like a house structure. Okay. So, this is the first step. So, when we take ethene, okay, so this intermediate is called ethene ozonide. Okay. So, now let us see the second step now. So, this is your first step. The second step is we take this ozonide and it gets cleaved like this into three parts. Okay. So, we will take the same ozonide CH2. So, this is the ethene ozonide. So, in the second step we reacted with zinc and H2O. Okay. So, now as I told you, so it will get cleaved this way. So, the use of this oxygen is to grab this oxygen. So, it will form one of the byproduct will be zinc oxide, and the two major products what we get from this is CH2O plus CH2O. So, this is nothing but your formaldehyde, which can be also written as HCHO. So, we are getting 2 moles of formaldehyde from this ethene compound. Okay. So, now we will see another example of the same type, a second example which will be an unsymmetrical alkene. Okay. So, we will start with the unsymmetrical alkene CH3 CH 2 CH double bond CH2. So, we can take it like this CH3. So, this is an unsymmetrical alkene. Okay. So, what compound is this? So, it is pent 2-ene. Okay. So, now this one I am going to do ozonolysis. So, first step as I told you, it is reaction with O3. Okay. So, let me write it here. So, first as I told you, it will react across a double bond forming like a house structure, that is CH3, CH2, CH. So, first let me cleave the double bond, then I will be adding the 3 O's across this carbon. Okay. So, now since we have taken pent-2-ene and this will be pent-2-ene ozonide. So, this will be the first step. Okay. So, in the second step, this ozonide will undergo cleavage using zinc and H2O. So, I will write the compound again, CH2, CH. So, it will cleave like this and like this. So, I use zinc and H2O. So, as I told you, the zinc will take this oxygen and form zinc oxide, and the major products are two aldehydes, that is CH3, CH2, CHO. So, this is propanal, 3 carbon aldehyde, plus I will take this aldehyde, that is CH3, CHO. So, this is ethanal. So, as we can see that from the two examples, we can get either 2 moles of the same aldehyde, or we can get a mixture of aldehydes like in the case of the second example. So, now this is not the only product, we can also get ketones. So, I will take another example. So, let me take 2-methyl but2ene. So, how do I write this structure? 1, 2, 3, 4. So, it is but2ene. Okay. So, 2-methyl. So, we will CH, CH3. Okay. So, when I take compound like this, so instead of a H, when there is an R group substituted, we will see what are the products. So, first one is O3, the first step. So, we will add this across the double bond. So, let me remove the double bond first. I have removed this double bond here. Then I am adding the 3 O's like this. Okay. So, what is the next step? I will continue here, zinc hydrolysis. This basically helps in the cleavage. So, it will break like this. So, this one will be taken up by zinc and it will cleave like this. So, let us see the products here. Now, let us write this part of the compound, that is CH3, C, CH3. This O will become double bond O. Okay. Now, plus we will write this part of the product, that is CH3, CH, O. So, now in this reaction we can see that a ketone and an aldehyde is formed. So, this is propanone and this is ethanal. Okay. So, this is another example. So, here we have seen a mixture of a ketone and an aldehyde is formed. Now, we will take one more reaction to see whether only ketones can be formed. So, same thing, I will take another example, CH3, CH3. So, instead of this, I substituted an alkyl group, then I will write it like this. Let me take this alkene. So, instead of a H, in both the cases, I am substituting with the R group. So, the first step is treating with ozone O3. Now, as I told you, it will get added across a double bond. So, we will get CH3, CH3, O, CH3, CH2, CH3, this will be forming a. So, the O3 will get added, as I told you, across a double bond. So, now what is the next step? So, this one we will react it with zinc and water, where the lysis of the bond will take place. So, as I told you, it will get cleaved here, here and here. So, what are the products now? We will see this part of the compound, that is CH3, C, CH3 double bond O, that is propanone, plus this part of the compound, that is CH3, CH2, CH3 here and double bond O. So, we are getting a mixture of ketones, that is propanone plus what is this 1, 2, 3, 4. So, it is butane, and in the second position we have double bond O. So, it is butane 2O. So, from these reactions we got to know two important things. Okay, let us come to the summary of this reaction. That is, one thing is we can identify the position of the double bond. Depending on the products. On the products formed. Okay, so this is the first thing. We can identify where the double bond is in a compound. Now, what is the second thing? So, we have seen in all these examples what we did, we are getting aldehydes or ketones, okay, or a mixture of aldehyde and ketone. So, it can be used for the preparation of aldehydes and ketones. And the third point is, it not only reacts with the double bond, it can react with, ozone can react with even triple bonded compounds, that is react with compounds having or hydrocarbons, I would say, that would be right, hydrocarbons having triple bond. And we can see that it will not react with alkanes. So, it will react only with alkenes and alkynes. So, for this third point, I will do an example. So, let us take an example with a triple bond. Let us take this compound. Okay. So, this is but2-ine. That is, in the second position we have a triple bond. This is little tricky. When I react with ozone, as I told you the concept, it will cleave only the double bond. It will not cleave the third bond. So, the intermediate will look like this, that is CH3C. We have to cleave only these two bonds. So, I will keep one single bond here, then I will have CH3. So, across this I will add the 3 O's like this, ozone. Okay. So, this is the intermediate here, and again when I do the cleavage of this compound using zinc and H2O, this oxygen will be taken by zinc. Please remember that this bond will not be cleaved. Okay. So, the cleavage will happen only across this O and O. Okay. So, this bond will remain intact. So, we will get only one product, that is CH3C. I am writing this compound as this part as it is. So, here I will form double bond O, double bond O. So, we will basically get a diketone when we use an alkyne. And one more thing what to be noted is, we will get only one product. Okay. So, only one product is formed, which is a diketone.